Okay, in this problem we are going to solve for the horsepower of the vehicle required to overcome tractive resistance at a given maximum speed, or the design speed, if you will. That's the maximum design speed. So tractive resistance, we can call it just simply R. Tractive resistance, TR, simply R, is nothing but a combination of aerodynamic resistance, rolling resistance, and then grade resistance. So you might want to pause this video just briefly and then read the problem, comprehend the problem before I can explain the whole thing. Now, what was given to us is a 2500 pound car, that's the weight of the car, designed to drive a maximum speed of 90 miles per hour, has a drag coefficient of 0.38 and frontal area of 20 square feet, and sea level air density. This is we are solving this problem at sea level. Sea level air density is given 0.002378 slugs per cubic feet. And what is the horsepower extended at this maximum speed? This is a straightforward application of the formula of RA, RL, and RG. So let's first take a stock of what is given to us. So what is given to us is the weight of the vehicle, which is 2500 pounds, and drag coefficient of 0.38, frontal area 20 square feet, air density, maximum speed of 90 miles per hour, and grade of 0%. Now the first one is aerodynamic resistance. So let's get to aerodynamic resistance, which is the equation given to you is rho over 2 CD times AF and V square. Now simple substitution of the values that are given to us. Oh, by the way, this template has already been set up, so I can minimize the writing while talking into the video. There won't be too many awkward pauses while I am writing. So let's first enter the aerodynamic, I'm sorry, the air density, which is 0.0023, come on, 0.002378 times drag coefficient 0.38, air frontal area is 20, and V square. This is given to us in miles per hour. To convert miles per hour into feet per second, you got to note this here. Area is in feet, which is what we have, 20, and velocity is in miles per hour. Rho is also in cubic feet, so it's fair to convert everything into feet, into the same units. 1.47 times velocity gives you the velocity in miles per hour gives you the speed in feet per second. That's what this whole thing is. 1.47. Let me get this period properly placed. Come on, come on. All you do is a circling here. Okay, there is. I think good enough. So that comes out to be 160.7 lb force. So be careful with all the units when you're solving the problems. Now the rolling resistance. The rolling resistance is this fella here, FRL times W. The FRL is a empirical equation given in terms of the velocity of the vehicle or the speed of the vehicle. So again, substituting the values, 0.01 times, pardon that mess over there, 1 plus, again you have to convert speed from miles per hour to feet per second, which is 1.47 times 90 divided by 147, and this whole thing multiplied by W is 2500. So the value comes out to be 47.5 lb force. So grade, since it's given as G is 0, the whole grade resistance will become 0. So now the total resistance or tractive resistance is going to be RA plus RL plus RG, which is nothing but 160.7 plus 47.5 plus 0, that's equals what did I do that, not 0, 208.2 lb force. So the next we will solve for from force to power. So from how do you convert from force to power? It's basically it's a force times velocity gives you power. Here the force is R and the velocity is the speed. So let's do this. 208.2 is lb force times velocity is actually 1.47 times 90. We are converting to feet per second, and that will come out to 27,540. 27,540. And what is the unit of this one here? Let's find out. Force here is lb force multiplied by velocity is feet per second. So this is going to be lb feet per second. And the horsepower equation is given by lb feet per second divided by 550 is the horsepower. So that's 27,540 by 550, and that will come out to 50.1 HP, and this is going to be your answer. By the way, you might notice that here I did not carry to the decimal. There is absolutely no point. I mean, if you want, you can put one decimal, but there's absolutely no point in going to several decimal points. So that's how to solve this problem. We'll see in the next problem.